Have you ever seen a bridge that stretches nearly a mile across a river without a single support standing in the water? At first, it sounds impossible. After all, most long bridges rely on massive concrete piers rising from the riverbed. But in eastern China, engineers achieved something extraordinary. The Jiangyin Yangtze River Bridge spans one of the busiest waterways on Earth without placing a single pier in the river. How is that even possible? More importantly, why would engineers choose such a difficult design? The answer lies in a combination of geography, economics, and some of the most ambitious engineering ever attempted. This isn't just the story of a bridge, it's the story of solving a problem that once seemed impossible. The Yangtze River is far more than China's longest river. It is one of the busiest commercial waterways in the world. Every day, thousands of vessels travel along its waters, carrying everything from automobiles and electronics to steel, grain, and fuel. Near Jiangyin, the river is especially important because it's one of the final stretches before ships enter the East China Sea. Massive ocean-going cargo ships, some weighing over 50,000 tons, pass through this section around the clock. Any structure built here had to allow these giant vessels to move freely without slowing one of Asia's most important shipping routes. Before the bridge existed, crossing the Yangtze here was surprisingly difficult. People traveling between Jiangyin and Xinjiang depended almost entirely on ferries. Under perfect conditions, the trip took about an hour, but the Yangtze rarely offered perfect conditions. Thick fog frequently forced ferry services to stop, while strong winds and heavy river traffic caused long delays. During holidays, vehicles lined up for hours just waiting to board. The only alternative was driving nearly 90 miles west to cross the Jiangyin Yangtze River Bridge before heading back toward the destination. What should have been a short journey often became a frustrating trip, lasting several hours. As factories multiplied and trade expanded across Jiangsu province during the 1990s, this bottleneck became a serious economic problem. Building a conventional bridge seemed like the obvious solution, until engineers studied the river itself. The Yangtze at this location is nearly 1,400 meters wide, with powerful currents flowing beneath the surface. Some sections are more than 60 meters deep, and the riverbed is covered with thick layers of soft silt instead of solid rock. Constructing massive bridge piers in these conditions would have been incredibly difficult and expensive, but an even bigger problem lay above the water. Every pier placed in the river would narrow the navigation channel, increasing the risk of collisions with giant cargo ships. Imagine placing concrete columns in the middle of one of the busiest highways in the world. That's essentially what engineers would have been doing on China's Golden Waterway. The river had to remain open, safe, and uninterrupted. There was only one realistic solution: a suspension bridge with a single giant span. Instead of supporting the roadway from below, engineers would suspend it high above the river using enormous steel cables stretched between two towers. With no piers in the water, ships could sail underneath without obstruction. Even during high tide, it was an elegant solution. But there was one enormous catch. At the time, China's longest suspension bridge had a main span of just 452 meters. The proposed Jiangyin Bridge would require a span of 1,385 meters, more than 3 times longer. It wasn't simply a bigger bridge. It was an engineering leap that pushed China far beyond anything it had ever attempted before. The question was no longer whether a bridge could be built. The real challenge was whether engineers could create foundations strong enough to hold thousands of tons of steel under constant tension while spanning nearly a mile without a single support in the river. The answer would depend on solving one of the biggest engineering puzzles of the 20th century. Building a suspension bridge begins long before the first tower rises into the sky. The real challenge lies underground, where the enormous pulling force of the bridge's main cables must be anchored. Imagine 2 giant steel ropes stretched tightly across a river. Every vehicle crossing the bridge increases the tension in those cables, and all of that force has to be absorbed by massive concrete anchorages buried deep in the ground. If either anchorage moved even a few inches, the entire bridge could become unstable. At Jiangyin, engineers quickly realized they faced 2 completely different construction sites. One riverbank offered solid rock, while the other consisted of soft, unstable sediment. It was like trying to build one half of a bridge on a mountain and the other on a giant sponge. On the Jiangyin side, the solution was relatively straightforward. Beneath the surface lay strong bedrock capable of supporting enormous loads. Engineers excavated nearly 20 meters into the hillside, before constructing a gigantic gravity anchorage directly on the rock. This massive concrete block would eventually resist tens of thousands of tons of pulling force from the bridge's steel cables. Once buried and secured, it became virtually immovable. But crossing the river revealed a completely different story. On the Jiangyin side, there was no bedrock anywhere near the surface. Instead, engineers found nearly 80 meters of soft clay, sand, and river deposits left behind over thousands of years by the Yangtze. Building directly on this weak ground would have been extremely dangerous, as the immense tension from the bridge could gradually pull the foundation out of position. Rather than searching for better ground, engineers decided to create it themselves. They first strengthened the site by placing thick layers of crushed stone and compacted sand. Then came one of the largest foundation operations ever attempted for a Chinese bridge. Workers drilled 96 giant cast-in-place concrete piles, each about 2 meters in diameter, extending deep below the soft soil into stronger layers underground. These piles acted like the roots of a giant tree, spreading the bridge's enormous forces safely into the earth. Afterward, the tops of all 96 piles were connected with a massive reinforced concrete cap, forming one solid foundation. In effect, engineers built an artificial bedrock capable of supporting one of the world's longest suspension bridges. Even that wasn't enough. Because the main cables would constantly pull horizontally on the anchorages, engineers added another layer of protection. Around the foundation, they installed 8 steel piles, each 3.5 meters wide and 30 meters deep, along with 8 gigantic gravity anchors, each weighing nearly 800 tons. Heavy steel tendons tied these components together into one enormous structural system. Instead of relying on a single foundation, the anchorage became a network of interconnected supports capable of sharing forces in every direction. This redundancy meant the bridge could safely withstand decades of traffic, seasonal flooding, strong winds, and even earthquakes without compromising its stability. With the foundations finally complete, attention shifted skyward. 2 towering steel and concrete pylons began rising above the riverbanks, each standing almost 200 meters tall, roughly the height of a 60-story skyscraper. These towers would carry the weight of the bridge through the massive suspension cables while allowing the roadway to hang gracefully above the Yangtze. Constructing them required extraordinary precision. Engineers constantly monitored every section using laser surveying equipment, because even a tiny error at ground level could become a major misalignment at the top. As the towers climbed higher, they became visible from miles away, signaling that one of China's boldest engineering projects was rapidly taking shape. Yet the towers alone could not hold the bridge together. The true stars of the project were still waiting to be installed. 2 colossal steel cables that would stretch nearly a mile across the river. Together, these cables would support the entire bridge, carrying a combined load of more than 128,000 tons, while allowing the roadway to float high above one of the busiest shipping lanes in the world. Creating those cables required an astonishing level of precision, and would become the defining achievement of the entire project. With the towers standing tall on both sides of the Yangtze, construction entered its most spectacular phase. The bridge's 2 main cables had to be installed. Although they look like giant steel ropes, each cable is actually made from 21,463 high-strength galvanized steel wires bundled together with incredible precision. Instead of manufacturing the cables in one piece, engineers built them wire by wire using a technique called aerial spinning. Specialized machines carried individual steel wires back and forth across the river thousands of times, gradually forming 2 enormous cables suspended hundreds of feet above the water. It was a slow and painstaking process, but it ensured that every strand carried its share of the load. When completed, each cable weighed more than 8,300 tons, making them among the strongest ever built in China at the time. Once the cables were in place, the bridge deck could finally be assembled. Hundreds of vertical suspenders were attached to the main cables, acting like giant hangars that would support the roadway below. Massive steel deck sections, each weighing hundreds of tons, were transported by barges beneath the bridge and lifted into position using powerful cranes. Every section had to align perfectly with the previous one, sometimes within just a few millimeters. Construction crews also had to battle strong winds that could cause suspended steel segments to sway high above the river. Often they waited hours, or even days, for ideal weather conditions before attempting a lift. Piece by piece, the gap across the Yangtze disappeared until the final deck section connected both sides of the river for the first time. Although the bridge appears completely rigid, it is actually designed to move. As thousands of vehicles cross each day, the deck bends slightly under their weight. During strong winds, the bridge gently sways, while seasonal temperature changes cause the steel to expand in summer and contract during winter. Rather than resisting these forces, engineers designed the structure to absorb them safely. Expansion joints, flexible bearings, and the enormous suspension cables work together to distribute stress throughout the bridge. This controlled movement prevents cracks, reduces metal fatigue, and helps the structure remain safe for decades. It's one of the reasons suspension bridges can span such incredible distances while carrying heavy traffic every single day. When the Jiangyin Yangtze River Bridge officially opened in 1999, it immediately changed transportation across eastern China. What once required an unreliable ferry ride or a long detour could now be completed in just minutes. The bridge quickly became a vital transportation link, carrying commuters, tourists, and freight vehicles between Jiangyin and Xinjiang while dramatically improving regional trade. At the same time, ships continued passing freely beneath it because there were no bridge piers blocking the navigation channel. It was a perfect balance between road transportation and one of the busiest shipping routes in Asia. The project proved that modern infrastructure could improve life on land without disrupting commerce on the water. The bridge also earned worldwide recognition. With a main span of 1,385 meters, it became China's longest suspension bridge when it opened and ranked as the fourth longest in the world. More importantly, it marked a turning point for Chinese engineering. The experience gained during its construction helped pave the way for even larger projects in the years that followed, including record-breaking bridges that now dominate China's skyline. The Jiangyin Bridge wasn't just a successful project. It became a classroom for an entire generation of engineers, demonstrating that China could design and build world-class megastructures capable of competing with the best in the world. Interestingly, the bridge's name has sparked discussion for years. Most Yangtze River bridges in Jiangsu are named after the two cities they connect. Yet this one is simply called the Jiangyin Yangtze River Bridge, even though it also links Xinjiang. One explanation is that Jiangyin, being the larger economic contributor, received the naming rights. Another popular belief is more symbolic. The name combines Jiang from Xinjiang and Yin from Jiangyin, quietly honoring both cities in a single word. Whatever the true reason, the bridge stands today as a shared achievement that transformed life on both sides of the Yangtze. Today, millions of people cross the Jiangyin Yangtze River Bridge every year without giving much thought to the incredible engineering beneath their wheels. Yet hidden beneath the roadway are massive anchor blocks, giant foundations, and two extraordinary steel cables quietly carrying more than 128,000 tons of force. Without a single pier standing in the river, the bridge continues to allow some of the world's largest cargo ships to sail beneath while connecting people, businesses, and entire communities above. More than 25 years after its completion, it remains one of the greatest examples of how engineering can overcome nature's toughest challenges, not by fighting against them, but by designing around them. If you enjoyed discovering the remarkable engineering behind the Jiangyin Yangtze River Bridge, don't forget to like this video, subscribe to the channel, and let us know in the comments which incredible bridge or mega project you'd like us to explore next. Thanks for watching, and we'll see you in the next video.